So now, okay, we got the warning for recording now, and I will then continue to say that we in this industry, the car industry, we live in a quite disruptive time right now. I usually say that the car industry has been boring for 100 years, and now finally some fun happens. And the key here is that you will see a lot of plastic grills today on the streets, because most of the OEMs right now, they produce electric cars and they want to show that. So they cover the grill with plastic, and you will see that. The problem is, and the challenge is, that there is a ghost in the background, the digitalization. So there is another disruption hidden behind the current one. The current one is electric, but the second disruption coming very, very closely is the digital disruption. And the way we will see this, I think, is that we will see the value of the non-digitalized cars drop very quickly. Because who wants a car which is not improved over time? Well, while the cars that have a digital platform and are being improved and developed during their lives in the customer hands, they will keep their value. So they will be valuable on the second-hand market as well. And then this difference here will be very, very important for a market, and this will create a real second disruption. So with this in the background, we go to our work now, and I show this first just to show that we are taking this seriously and we are doing things good. Earlier, when you tried to buy a car, you could buy actually about 1 billion different variants of it just by ordering from the web page. So you look at the Volvo Cars web shop, you try to configure your own car, you can actually create billions of variants of that car. And of course, we sell it. This will efficiently stop us from having a well-defined software product, and it will also efficiently stop CI, actually. That was the situation where we lived earlier, and this company has actually taken this seriously. We are moving quickly towards a situation where we have market variants, because in different countries, they have different variants. We need that. And also we need a few trim levels. But this is a very, very different, there are many, many orders of magnitudes gone here, sort of. This allows us to have one software product, which we actually can configure for different vehicle types on a product line. So that sort of we can develop for one software product, which can be configured for several different kinds of vehicles. This is much more like a smartphone. We can then also have a very sort of a well-defined CI process. This is not vanilla CI, but we can define a software product with CI for this car product. It works. And then we can take the opportunity of digital personalization, and turn the whole thing around and make the product that the customer has very, very individual anyway, using digital. So we switch value from the hardware world, from the t-shirt world, to the digital world where the value is in the software. The cars in the future will look much more similar to each other. They will look much more the same, just like you buy an iPhone, just as Jonn mentioned. So I made this very, very rough sketch and wrong sketch also of our car architecture. This is only the car part of the product architecture. It's wrong and it's a sketch, but I apologize for that. But it shows the basic layers. And the challenge now, taking into account a lot of legacy code also, is to create a service, what I call sort of make the commodity domain service based. So you can control those commodity services from a sort of an updatable product control layer, and then allow us to have a lot of differentiating features on the top. Remembering that it actually can be differentiating to control the seat, which is a commodity thing in the car, from the smartphone. So with this sketch sort of in place, I think you can understand that we have a lot of legacy code to take into account and play with, but we won't rewrite the whole thing. You cannot just rewrite legacy code. You have to deal with it, as said earlier also. We also want to enable things like A/B testing here. We are doing our first successful A/B test right now in the cloud part of the product. So in the outside of this picture, we also tried, to move down the vehicle architecture here to do this even further, lower. But the lower you get, the more into the commodity car you get, and there things get more stable and also more secure. So If we then turn the technical picture into a people picture, the company has of course understood that yeah, we need to change things. And this falls down to, of course, we need to recruit a lot of good talents. We need to work with our tools. The tools we have now, they might not be perfect for the future, and we need to work with that. And we need to create a culture where we can actually have a sustainable software product in place, and a shift of governance and mandate in the company for the software culture. And if we sort of elaborate with this a little bit more, we get this very complicated picture, but there is one important thing in the middle, which is sort of the software team. So the idea here is to create a software culture with a software team in the middle. Above the software team, you have this word software craftsmanship, and this is the most important message in the whole picture, sort of that we need to build a software craftsmanship. Then you have to recruit at all levels, not only young hackers. You have to recruit senior people. You have to build up a software craftsmanship, both in the code and in the people over a long time. This will take a while. One part of this is to have software engineering ownership, so that the engineer, we're coming from a world where we bought software, and usually also we can even buy a platform from a supplier, then integrate our own software on that platform, and then we buy the outcome of that little sub-product to the car. It's a quite complicated process. This also creates, of course, a variety of different ways of developing code in the company. So software engineering ownership comes with a much more uniform way of developing code. It also comes with an iterative workflow. There will be no big technical leaps in that way, because the software is a much more evolving product. It's much like a cat, I usually say. We also want to use much more data-driven development. And we have started with A/B testing. We are doing sort of small pilots on that. We need to, of course, to grow that in real sense. But also we have to remember that the car is 2 tons of metal moving with a high speed. It's kind of dangerous. And we have regulatory dependencies. We have cyber security on top of this. Miroslav will talk more about that. So we have the safety aspect and the security, which is super important. If you go around a little bit more, you'll see this software engineering competence there. This is a mechanical company at its base. So the mechanical people has to be taught how the software product works, because otherwise we cannot combine those two worlds. We cannot have sort of competing parts of the company working alone. We need to work together with one product. So that is also a huge challenge, actually. But now I will switch over to Miroslav, taking the second half here with a kind of similar slides. I wonder how you do now.
Exactly. So Jonn was talking about Volvo, and I would like to say first that my journey with Volvo started about 15 years ago, and then by that time I actually met a colleague who was coming from the electrical department, and he was working with boxes and cables, and there was some software inside, and some of there. And now today, 15 years ago, I mean, we're talking about software engineering being one of the core disciplines at Volvo. I mean, software being the most disruptive technology in the cars. As I will show you later with all the cybersecurity. So the software in the car is not only part of the electrical system. It's not only software in the car, the actual 2 tons of metal that Jonn is talking about, but software is now integrated with the cloud. So the car without the cloud, without the IT department, which is no longer even called the IT department. I think it's called Consumer and Enterprise Digital Department. It shows just how the company has changed over the years. And for your record, I'm not paid by Volvo to say those things. I'm just super impressed the way they actually did this journey. And if we talk about things, for instance, like the software engineering competence, which Jonn talked about a bit, I mean, it's not only about taking a mechanical engineer and teaching him or her how to do coding in Python. It's also about integrating the mechanical engineering and software engineering, and also evolving the software engineers over time, because the technology that the university teach today, they're not going to be out there in 10 years time. I mean, we have to teach the students, and Volvo has to also reinvest in their competence and talent attraction programs, people experience, visualization of things. We can go to the next slide, Jonn. Yes. So one of the things that are important in this context is the disruption which is brought by what Jonn talked about, commodity and the architecture. So one of those big things that is happening at the company is also the fact that it's been evolved in the area of, for instance, open source. So the company no longer talks about open source as something that being there and let's not talk about that. I mean, now we're talking about open source very openly. What kind of licenses are there? What the company should take and should not take into the car? What are the risks related to that? And if you take on the next slide, this is the big discussions that are happening is about what should be proprietary and what should be open source. No longer whether we should use it, but which parts of that should be. And the company is moving away from even some of the early open source projects like the Geneva infotainment system onto other platforms like the Android community or Android Auto. And one of the reasons behind why this move happens is because the company starts to observing the community behind the open source product. It's no longer only the source code that people are thinking about. It's also the community. Is the community alive? Is the community going to be alive in 5 to 10 years time when we're going to support the cars, and how do we do that? If you take the next slide, Jonn, here you can show me a bit about how you think about the licenses. So it's no longer black and white when it comes to open source, but it's a very aware process within the company and also involving the legal department about the kind of licenses which are being used. So not only taking something from the internet, but also looking at what is it that we actually take and how do we take that into our product development. And maybe even in the future, as I will show you in a moment, starting to think what we are giving back to the open source community. So the company becomes a real people experience. The young people that are coming from the university suddenly see Volvo as a company that's really, really cool to work with. It's no longer the mechanical kind of place which some people think, but it's a really cool company to work with. They work with open source, they work with visualization, cybersecurity. Those are the top of the things that, at least when I talk to my students, they want to work with. If you move to the next slide, Jonn, it's just a few initiatives that you can see that Volvo is not the only company moving towards that kind of open source development. I mean, of course, Toyota and Volkswagen are also moving there, but also Porsche, also Chinese developers and Chinese companies are recognizing the fact that working together on open source software is actually decreasing the costs. And this is just a few, these are 4 examples of different open source projects. But if you go to GitHub, what you could do today even is that you could see companies like Microsoft having their own AirSim platforms where you could test your autonomous vehicles on those platforms. And if you move to the next slide, there are, of course, the open source elephants, the big companies that's been around there for ages, like, for example, the Geneva Alliance, which I always use in my courses when I teach the students how automotive software could look like in the open source. But then also newcomers, like, for example, the NVIDIA. So for 5 years ago, people were not really taking NVIDIA as an automotive company. Today, they provide a drive software stack that is completely open source. You can take and you can play around with that. That opens up not only for the company itself, but also for us at the university to teach our students how to work with automotive companies. What is really cool about automotive companies, and even those companies like the Autoware.ai, which is a software for autonomous driving technology. So for 10 years ago, it was all of that was proprietary. Today, there's a lot of that in open source, which are, of course, driving the development of the automotive sector enormously. And if we go to the next slide, what happens also with companies is that they are looking a bit more about the trade-offs of that. So this discussion between commodity and the cool features that are built on top of that becomes really, really important for all companies in the automotive software. The companies are not and Volvo is one of them, is not only looking at the open source software as a platform, but also about the disruptor. How do we build something really, really cool on that open source platform? How do we make sure that out of those 10 different cars in the parking lot that look exactly the same, that you want to buy that particular car that comes from Volvo? So if you go to the next slide, Jonn, maybe even the next one, I think one of the things I really want to stress is that if you look at Volvo Cars and website, the volvocars.com website, you could go there and you could take a look at the open source portal. A lot of information for developers, by developers, about how the company and how the development organization actually looks at the open source. And not only inside the company, but if you go to the next slide, can I switch it? Yes, I can maybe switch it. So the developer community, there is this website, developer.volvocars.com, where you can just go and download open data sets for software development. You could even play around with a 3D simulator and download the Unity engine simulator, a Unity engine based simulator for Volvo XC40. So you can build your software and test your software. And of course, you can even make the company to look at the providing the possibility of outside of developers to actually do in-car development, in-car apps, things that I've always dreamed about when I was thinking about Android Auto and actually cool features in the car, because I want to be able to build apps for my car. I know Jan wants to wait for somebody else to update his car. I want to be the one actually updating my own car by myself. And I think that's the coolest feature that you could ever have for this. If you move to the next slide, Jan, yeah, this is just how it looks like. I mean, I looked at the Cirrus dataset with one of my PhD students, and it actually contains exactly what you need to be able to train machine learning vision algorithm on different data sets. So you have bounding boxes, you have, predefined data sets that are really, really high quality. If we move to the next one, maybe even the one after that, here's where it becomes really interesting, because now that you allow everybody to be part of this development and you want to update the car, and the car's functionality is becoming more secure, more safe, it has to be standardized, has to be certified, but also the channel where you deliver this functionality, over-the-air update, also has to be certified and safe. So suddenly the question of cybersecurity pops up as the top question for the development. It's no longer just something that happens, but it's a question: how do you realize that in the car, the content of how do you make the content of the car secure, certified, but also how do you make the channel certified? So the electronics and software department, or software electronic department developing the actual electronics and software in the car has to work with the IT department, which delivers the software to the car while it's done, and also building up the understanding of how the software is updated over the life cycle of the car, in order to be able to understand if something goes wrong, which exactly software versions were downloaded on that particular car with a specific VIN number when it crashed. And not only for liability, but also for understand how do we improve and prevent those kind of accidents in the future. So I think the last slide I have is, if you take the next one, Jan, it is about the cybersecurity and also cybersecurity management systems. So not only the actual secure software, but also the way, how do we manage security? How do we know if by the new security threat, how do we know where to look for that security threat in the cars? Which cars exactly to fix and how to fix them? And also, in the future, which libraries and which tools not to take if you would like to update and develop software that is secure, that prevents those kind of incidents. So I think, to sum up, in the last slide, I think, Jonn.
Yeah, may I mention, but I think also we should look on this also from a company's perspective, that it is so enormously costly to have a security brake or a safety brake in a car, so that the company, I mean, I'm not sure we need the certification as a tool. I think that the value of the security and the safety is so high, so the company might drive that itself. So
Yeah.
sorry.
But you agree that this is a disruption. I mean, we no longer talk about security in the box. It's the entire company.
Yeah.
And the last trend that I think is the coolest trend, I think, at least from the metrics and data perspective, is the fact that we talk about KPIs, but not in the KPIs in the traditional mechanical way. For example, have you tested your software? Have you designed your software? Have you done requirement review? But more in terms where every empowered team creates their own small KPIs and their own small status reporting tools that serve their purpose. So this is an example from the electrical propulsion system, which collects metrics into one database and uses different kind of reporting tools like Power BI, reports, Excel, dashboards to be able to visualize the status of that and actually discuss the status on their status meetings. So that's something that at least I remember Kent and I looked at a few years ago. Yeah.
I haven't convinced the electric team yet to use A/B testing, actually, because then you can take this to a next level.
Yep.
When you use customer data in their KPIs, and then you reach the value modeling that Jonn used to talk about. So we're not that far from that, actually, and this will be disruptive from the development side.
Exactly, and I think that's if you look at 15 years ago, where we're talking about cables to this, I mean, this is a tremendous journey. Anyway, that was my last slide. I think the last one is just the summary. So anyway, just wanted to say that when I got this opportunity to stand in for Kent, and when he talked about these things, I felt at least super excited about how this all worked in the last few years and where this is all going, so to say. So I'm really keen on to seeing new things, what's going on around the corner.
You're a very nice independent observer, I must say.
Yeah, and again, I'm not paid at all by Volvo. I'm just super excited. I mean, I haven't seen a company that's done this kind of transformation for a few years now. Anyway, thanks a lot for this. Jonn, do you want to wrap up and say something?
No, it's fine. You did it perfectly. Do we have any questions here? Because we might have 1 minute left for that.
Yes. Actually, 3 minutes. Any questions? Maybe I started.
We have one in the chat.